Rational functions. What is a rational function? It's a function of the form f of x equals p of x over q of x, where q of x can't be 0. And p and q are both polynomial functions. A quick review that we just saw up on the board. If you have a polynomial that's the definition of a polynomial, right, in general form? You don't see it, but there's really an x to the 0 there by the constant term. So if you have a polynomial that is, say, just p of x equals 7, the degree of that polynomial is 0. Because it's 7 times x to the 0 power. X to the 0 is 1. All right, before we go, I wanted to review that because here we go. We have seen several rational functions. These two were in your parent graph back in the last chapter, right? Y equals 1 over x, the reciprocal function. Do you see that that's a polynomial? Y equals 1 over a polynomial y equals x. What's the degree of the numerator? Y equals a constant. What's the degree? 0. What's the degree of the denominator? 1. This is going to come in handy later, I promise. For the reciprocal squared function, what's the degree of the numerator? 0. What's the degree of the denominator? 2. Y'all remember seeing these two functions? The reciprocal and the reciprocal squared? And the reciprocal was up here in quadrants 1 and 3. And you notice that there are lines that these never touch, right? Right there and right here. Same thing on the reciprocal squared, 1 over x squared. There's a line that that function never crosses, and a line down here that the function never gets to. Those are special. We're going to talk about those in just a second. Okay, let's go talk about vertical asymptotes. The line x equals a is a vertical asymptote of the rational function if this says the y values approach infinity, or it could approach negative infinity, as x approaches the value a. The y value either goes to positive or negative infinity as the x value goes to a. Meaning, when you approach a from the left or the right, what's the y value doing on this side? It's going up to infinity. If you approach a from the right, what's your y value doing? It's going down to negative infinity. Something I want you to notice, the graph of a rational function can never cross a vertical asymptote. That's important. The vertical asymptote is right here on this graph. That blue function will never cross that orange vertical asymptote. Got it? How do we find vertical asymptotes? First thing you want to do is write the rational function in lowest terms. You want to factor everything and cancel common factors. Cancel common factors. Those common factors produce what are called wholes. The common factors are wholes. Everything that remains after you cancel common factors, everything that remains in the denominator, you set it equal to 0, solve for x. Those are your vertical asymptotes. Common factors are wholes. Everything left in the denominator, set it equal to 0. Those give you vertical asymptotes. Let's go do it. Find the vertical asymptotes and wholes. Y equals 1 over x plus 2. It's factored. Are there any common factors in the numerator and denominator? No. So the rule said to set everything left in the denominator equal to 0 and solve for x. There is a vertical asymptote at x equals -2. If I were to go graph this function at -2, I would want to draw a vertical asymptote. You said that there were no common factors to cancel, so I'm going to remind myself that there are no holes on that graph. Yes? We're going to see in this next example what a hole is. Number 2, everything is factored. Do you agree? Yeah. Are there any common factors? Yes, x plus 1. So I'm going to set x plus 1 equal to 0, solve for x. I have what's called a hole at x equal -1. Okay, what would the y value be if I were to plug -1 into what's left right here? So I'm going to say there is a hole at the point -1 something. How do I find that something? I plug -1 back into the remaining function. I have -1 minus 4 over -1 minus 3. So that's -5 over -4. I have a hole at -1 comma 5/4. I'll show you what that looks like on the graph in just a second. Vertical asymptotes. Is there anything remaining in the denominator that I need to set equal to 0? X minus 3. When I solve for x, I get x equals 3, so there is a vertical asymptote at x equal 3. You have to put the letter here. You can't just say that there's a vertical asymptote at 3. You have to say there's a vertical asymptote at x equal 3. Okay, if I were to try to graph this, there's a vertical asymptote at x equals 3. And where did I find the hole? At -1 5/4. So -1 5/4, there's a hole right there. Go to your calculator. I want to graph x plus 1 times x minus 4 over x minus 3 times x plus 1. When I'm putting that in, I need to say, here comes my numerator. Open your parenthesis. What is my numerator? X plus 1 times, what was it? X minus 4. Okay, do you see how I put a double set of parentheses around all that? I have to have the parenthesis around the whole numerator. Now say divided by. I need parentheses around my entire denominator. And what was it? X minus 3 times x plus 1. Graph. I didn't put the second set of parentheses in there, did I? Second insert parenthesis. All right, graph. Do you see the Nope. Do you see the vertical asymptote at x equal 3? What happens if I hit trace -1? What's my y value? Nothing. There's a hole there. The pixels are too small for you to see that hole drawn on your calculator, though. Your graph looks like this. Kind of cool. We're going to put other pieces together to be able to get a better graph by hand in just a second. What I want to point out, your calculator is not going to show you that hole, but when you're graphing it by hand, you better put it there. Okay, go do it again. Go find holes and or vertical asymptotes if there are any. Number 3. It's factored. Are there any common factors? No, so there are no holes. I need to set 7x minus 5 equal to 0. 7x equals 5, x equals 5/7. That's a vertical asymptote. Questions? Number 4, is it factored? No. Can you factor it? I hope. You get x plus 1 over x plus 1 times x minus 2. Are there any common factors? Yes, x plus 1. So x equals -1, there's going to be a hole there. Where is the hole? -1 something. What is that something? What's left up top once I cancel the common factor? A 1. And on the bottom I'm going to have -1 minus 2. So I get a hole at -1, -1/3. Questions? Are there any other factors in the denominator? X minus 2. So I have a vertical asymptote at x equals 2. If I were to go start to graph this at x equals 2, I have a vertical asymptote. At -1, -1/3, I have a hole.